Section 4.4, exponential and logarithmic equations. So we've gotten into, now we're going to solve exponential and logarithmic equations, whereas before we knew how to graph them, we learned how there were some properties that we could use, and then we learned how to expand and condense, and all that's going to tie into 4.4. So the good thing about 4.4 is you actually have different strategies you can try depending if you're given an exponential or if you're given a logarithmic. So you definitely need to be able to look at an equation and say if it's exponential or if it's logarithmic, which is not that challenging to do, because for logarithmic, you're either going to see the words log or you're going to see the word or the letters ln for natural log. Log or ln means it's logarithmic. If you don't see either of those, then you know it's exponential. So we have different strategies. We have 3 strategies for exponential, and we have 2 strategies for logarithmic. So strategy 1 is for exponential. Strategy 2 is also for exponential. And then strategy 4 is for exponential. So you get to try either of these strategies. Do they all work? 99% of the time. Most of them will work. Once in a while, number 1 would not work. But I will give you some ideas of when you use each different strategy. So the first strategy, number 1, says rewrite the original equation so that the bases are the same. Now, why would you want the bases to be the same? Because this means you can set the exponents equal to each other. Now, what if you can't make them have the same base, or it doesn't really work out to where the bases are easily seen to be the same? Well, then you could try strategy 2. Strategy 2 says rewrite an exponential equation as a logarithmic. So this is when we talk about doing the circle, where we change exponential into a logarithmic equation. And I would say try this when you have just one exponent. And the last strategy for exponentials is you could take the log of both sides or the natural log of both sides and then simplify. And I would try this when you would have 2 problems of exponentials. So looking at number 1, I am going to show you all 3 strategies so you can have an idea of how they all work. So strategy 1 says you want to make them have the same base. So I want 4 to the x to be 4 to some power for 1024. So how do we do that? Well, you just take a guess. Remember, numbers get really big quickly with exponentials, so don't go too high. For example, 4 to the 5th is 1024. So I know 4 to the 5th gives me 1024. So strategy 1 says if you have the bases the same, you can set the exponents equal to each other. It's already solved for you, so my answer is x equaling 5. But what if we didn't really understand or know that 4 to the 5th power was 1024 and we didn't want to guess? So let's do strategy 2. Strategy 2 says take the exponential and change it into a log. So if you remember how to do the circle like we did in the previous section, we say log base 4 of 1024 equals x. So start off with log base 4 of 1024 equals x. And then we know change of base from the previous section, so we can do the log of the top divided by the log of the denominator, and that gives us log base 10 now. So log of 1024 divided by log of 4, and we still get an answer of 5. So our answer is still x equaling 5, and that's strategy 2. Now, what if we said, okay, don't really like strategy 2, what about strategy 4? Well, strategy 4 says take the log of both sides or the natural log of both sides. If I had an e, I'd probably take the natural log, but if I just have a regular number, not e, then I probably would take the log of both sides. Be careful, MyMathLab maybe says to change it into natural log, so make sure you use natural log instead of log. And again, MyMathLab will tell you. So I'm going to take the log of both sides, so I'm going to do the log of the left equaling the log of the right. So I'm not doing the circle, I'm taking the log of both sides. Now why would I want to do that? Because we know from expanding that our power can come down. So we get x times log 4 equals log 1024. And then we just need to solve for x. So to solve for x, we divide by log 4 and divide by log 4. So as you can see, strategy 4 actually changes the base for you, just like strategy 2 we had to do. So log 1024 divided by log 4 is just x equaling 5. So with this problem, each strategy does work. So let's go ahead and try strategy 2. So strategy 2, we're going to take an exponential and write it into a log. So looking at number 2, we have 2 to the 3x plus 2 equaling 0.0625. As you can see from here, it is still an exponential because we don't see a log or an ln. So if we want to try and guess 2 to what power gives me 0.0625, we could. Strategy 1 still works, but I'm going to go ahead and do strategy 2. Strategy 2 says change exponential into log. 0.0625 will equal 3x plus 2. So this is just a strategy that I decided to try. Again, sometimes if you try a strategy and it doesn't look so good, try a different one. So now at this point, I'm going to do my change of base. So the log of the argument divided by the log of the base still equals 3x plus 2. So in my calculator, I'll do the log of 0.0625 divided by log of 2. And I end up with -4. So -4 equals 3x plus 2, and now I can solve that equation pretty nicely. Subtract over the 2, so we get -6, and then divide, so x is going to equal -2. If you want to try the different strategies, go right ahead. Try a different strategy and see if it still gives you an answer of x equaling -2. For example, some of y'all realize that if I raise it to a negative exponent, say like -4, I get 0.0625. So strategy 1 would say, make them have the same base, and then set the exponents equal to each other. So if I had 3x plus 2 equaling -4, I'm already down to that point down there. So lots of different strategies to try. So let's look at number 3. So for number 3, we have 2/5 raised to the x power equaling 16 over 625. Again, if you want to try strategy 1, you want them to have the same base. So could 2 and 16 have the same base? Sure, a 2. And 5 and 625 could also have the same base. But again, what if you're not too sure what that power would be? Then try strategy 2 or strategy 4. Since I haven't shown strategy 4 that much besides number 1, I'll show strategy 4 here. So strategy 4 says take the log of both sides. So I'm not doing the circle, I'm just taking the log of both sides. And then what happens here, the reason why we do that is because powers can come down in front because of expanding. So I'll bring the x down. Remember, logs are just exponents, so they're just numbers. So you're going to have x. All we have to do is divide. So we'll divide by log of 2/5, divide by log of 2/5. So taking our calculator and plugging that in, we're going to have the log of 16 divided by 625 divided by the log of 2/5. And we end up with 4. If you don't like that strategy, try a different one. I would probably stick with strategy 2 most of the time. Get used to doing that strategy, but again, knowing more than just one strategy will help. So if you go down a road that doesn't look so nice, you can try a different strategy. So I'm going to let you do number 4, but I'll give you the answer. The answer should be x equaling -3. So try that problem out with whatever strategy you want. All right, so now let's go back to logarithmic since we haven't talked about those strategies yet. So 3 is for logarithmic, 5 is for logarithmic, and then the asterisk is for logs. So just like we had in a sense 3 strategies for exponential, we have 2 strategies for logs, but we also have a check. Why do we have to check for extraneous solutions with logs, but we don't have to check for exponentials? Well, exponentials, if you look at the graph of an exponential, the domain was all real numbers. So going back to one of our problems, we looked at this example, domain for an exponential graph was all real numbers. But for a log graph, if we look back at a graph of a log, we'll see that the domain for a log graph is 0 to infinity. So there are some values of your domain that are not going to work. So when you are dealing with solving log equations, you got to make sure you check your answers. You don't have to check for exponential. You should to make sure it works, but you must check for logs. So strategy 3 says rewrite a logarithmic equation as an exponential. So we're going to do the circle, but going from a log to an exponential. And I would say try this when you had 1 log. And then for strategy 5 says if the logs are equal, then the arguments are equal. And you're going to try this when you have 2 logs. So there's only possibility, 2 log equation or 1 log equation. Those are your only possibilities. So logs are a little bit more streamlined. If you have 1 log, you're going to try this. If you have 2 logs, you're going to do this. So let's go ahead and try some problems. So number 5. Is this a log equation or an exponential? Again, whenever you see log or ln, you know it is a log equation. Just like number 6 is also a log equation. Now number 7, some students always want to say that's log. That is not log. There is no log, there is no ln, so it's definitely not a log equation. That's just back to an exponential. And 8 is also exponential, 9 is back to a log, and 10 is back to a log. So for log equations, we have strategy 3, 5, and asterisk, 3, 5, and asterisk. For exponentials, we have strategies 1, 2, 4, 1, 2, 4. I will not be asking you on the test which strategy you're trying, but it is good to know which one you should attempt. So for log equations, we either have 1 log or we have 2 logs. Those are only possibilities. We have 2 logs, so strategy 3 is out, and we have to do 5 and asterisk. Well, what does strategy 5 says? Strategy 5 says if the logs are equal, then the arguments have to be equal. So we're going to set 2x plus 1 equaling 2x minus 3. Please do not think that I've crossed out my logs. I have not. The strategy says if the logs are equal, then the arguments are equal. And then if I solve that equation, you're just going to get x equaling 4. But don't forget we had the asterisk. The asterisk says we must check our answers. So when I put a 4 there, 4 plus 1 is 5, and we have the natural log of 5, which we can do. And when I plug in a 4 here, 4 times 2 is 8, and 8 minus 3 is 5, and we can take the natural log of 5. What can we not take the natural log of, or log of? We can't take the logs of zeros or negatives. So for number 6, how many logs do you see? 1, 2, 3. We only have a strategy if we have 1 log or if we have 2 logs, but we have 3 logs. So we have to condense to make it into either 2 logs or 1 log. Well, the left side says if I am having 2 logs that are subtracting, I can condense them, and subtraction would condense back into division. So I get the log of 4x divided by x minus 1 equaling the log of x plus 6 still. So we have to condense. So what strategy should we use? Well, we still have 2 logs, so my strategies are going to be 5 and asterisk. So I have that the logs are equal, so now I can say the arguments are equal. So 4x over x minus 1 is going to equal x plus 6. Now we're back to 116 material, which is solving a rational equation. So we're going to multiply both sides by x minus 1 to get rid of the fraction. So on the left side, they just cancel, but on the right side, we're going to have to multiply all that out. So x times x is x squared. Outer gives me a negative x, inner gives me a positive 6x, and last gives me a negative 6. So 4x is going to equal x squared plus 5x minus 6. Now this is quadratic, so with quadratic equations we normally want to make them equal to 0. So we're going to subtract over the 4x, so we're going to end up with 0 equaling x squared plus x minus 6. And then we need a factor. So factors of negative 6 to add up to a 1 would be x plus 3 and x minus 2. Set each factor equal to 0, so we get x equaling negative 3 and x equaling 2. But again, we got to make sure that we can use the values that we obtain. Don't throw out negatives just because they're negative. Don't keep positives just because they're positive. When you have a log equation, you got to plug it in and make sure you're still taking the log of a positive number. So when I plug in a 2 here, I get the log of 8, which is fine. When I plug a 2 here, 2 minus 1 is 1. That's fine. When I plug in a 2 here, it's okay. But look at we have log of 4 times negative 3, that gives you negative 12. So this is considered extraneous. So the only answer we keep is x equaling 2. Now, sometimes you'll keep 2, sometimes you'll keep none, sometimes you'll keep 1. So don't just think you always have to throw out negative answers. It all just depends. All right, so now let's look at number 7. On number 7, we have exponential. So we could do strategy 1 that says if they have the same base, the exponents are going to be equal. Well, that's already made for me because e and e are the same base. So all I have to do is set x equaling to 3x minus 4. So I'm going to do strategy 1. And if I solve that out, I'm going to end up with x equaling 2. Don't have to check with exponentials. So on number 4, we have 2 to the 5x minus 2 equals 8. We could do strategy 1 because how could 8 have a base of 2? Well, that would be 2 cubed. And since the bases are the same, then we can set the exponents equal to each other. Add over the 2 and divide. We're going to end up with x equaling 1. Other strategies to try if you want, but I went ahead and did strategy 1. Now, what if we want to do strategy 2 instead? Strategy 2 says do the circle. So log base 2 of 8 equals 5x minus 2. Then do change a base in your calculator. So log 8 divided by log 2, and that would give you 3. So 3 equals 5x minus 2. And again, we're going to solve it by adding over the 2, dividing by 5. We still get x equaling 1. All right, so now let's look at number 9. Now we're back to a log equation. For log equations, we're either going to have 1 log or 2. We have 2 logs, and so now we can use strategy 5 and asterisk, not strategy 3 because we had more than 1 log. So if the logs are equal, the arguments have to be equal, and then we're going to take the square root of the left and the square root of the right. But don't forget when you put in the square root, you have to have plus or minus. So we get plus or minus 2. Are we allowed to keep both answers? Well, when I plug in a 2, 2 squared is 4, that's fine. When I plug in a negative 2 squared is also 4, so it's fine. So you could have plus or minus 2 as your answers. Number 10, we have log base 8 of x equals 2. We have 1 log, so strategy 5 is out, and we're going to do 3 and asterisk. So strategy 3 says change a log into an exponential. How do we do that? By doing the circle. Hopefully you're good at that. So 8 to the second equals x. We get rid of our log because we're changing a log into an exponential. So we end up with x equaling 64. And then we're going to check to make sure we're allowed to use 64. Plugging in the 64 here, that's still a positive, so we're able to take the log of a positive. Remember, you just can't take out log of a 0 or a negative. And so that's going to finish up part A of this section, and then we're going to start part 2 on the next recording.